Hey everybody, Mr. Covey here, and we're on page 9 of your note packet, and we're talking about logarithms. Okay, you probably remember that you learned about logarithms in AAA or AATH, but you probably did well on them. Like you guys do well and stuff. But you probably, if I just ask you conceptually what a logarithm is, I think a lot of you guys would struggle to explain what is this thing in math and what does it do and how does it work exactly. And that's what I want to try and get you guys to have a better understanding of what a logarithm is coming out of PCA, okay? So let's start over from scratch really quick. I just want you to think about math. Think about math, specifically think about solving equations, okay? Just come into this with an open mind, and I think you'll understand logarithms better afterwards, okay? Here is an equation that you've been solving for 5 years. X plus 2 equals 16. The equation has addition. You know to solve that equation, you subtract 2 from both sides, you get x equals 14. You know in order to undo addition, you do subtraction. You know that. Why? It's because addition and subtraction undo each other. They are, if you want to use a fancy math word, they are inverse operations. They undo each other. Okay? And you know addition and subtraction undo each other. You've known that since elementary school. Okay? The fancy name is that they're inverse operations. Every operation in math has an inverse operation. Okay? That is a core concept of math. Okay? Take a second right now. Pause the video. Do the same thing we just did for B, C, and D. Okay? Pause the video. Actually pause it. Do the same thing we just did for B, C, and D. Okay? Okay. I'm assuming you pause it. For B here, you should have said it started out with squaring. In order to undo squaring, you did square rooting. Why? Because they're inverse operations. Okay, and you guys know you square root both sides, you get x equals plus or minus 4. This one started out with multiplication. In order to undo multiplication, you do division. You guys know that. Multiplication and division are inverse operations. The last one is the interesting one. It is 2 to the x power. You know how to undo exponents when they're numbers. You undo squares with square roots. You undo cubes with cube roots. You undo exponents. How do you do it? So one idea would be maybe you do something like an x root. That's not a thing in math. It's a good idea though. How do you cancel out an x exponent with an x root? It's not a thing in math. Okay? You obviously don't divide both sides by 2. Dividing by 2 undoes multiplication. That undoes this. It doesn't undo 2 to the x. Okay? So you need a new thing here. You need a new operation that undoes exponents. Okay? That new operation is called logarithms. Logarithms is an operation. It undoes exponents. Okay? If you wanted to write a fancy little sentence under what is a logarithm on the next page, I'd write logarithms are the inverse operation of exponentials, or of exponentiation, if you want to be fancy. Use it as a verb. Logarithms are the inverse operation of exponentiation. There is a way to undo 2 to the x equals 16. You need to use logarithms. Now, if you're sitting there dude, I know the answer to this was just 4. Because 2 to the 4th is 16. Yeah, cool. Except for if I said, okay, 2 to what power is 7? Well, I don't know. It's not 3 because that's 8. It's not 2 because then you need an actual operation to give you more exact answers. Cool. And that inverse operation is called the logarithm. Okay. So here's what a logarithm looks like. Pay really close attention here. Logarithms ask questions. Okay. What? I want you to think. Don't even write this down. Just think for a second. You know how a square root actually asks a question? So if you think about when I write up square root of 16, I know you guys know the answers for. But if you think about how you answer that in your head, aside from having it memorized, you actually don't think about square roots, because square roots are confusing. If I ask you what the square root of 16 is, you actually say, oh, what squared is 16? That's the question that comes into your head, or at least comes into my head. And that's how I think most people think about square roots. They think about squares. What squared is 16? And then they answer that question. No, 4. Okay? So square roots ask the question, what squared is 16? And that's the good way to think about square roots. I think that's how you guys think about square roots. Logarithms ask a similar question. Okay? They ask a question. It's a little more complicated question, but it's kind of like a square root question. So here's what a logarithm looks like. You have an log. That's just the operation. It's kind of like the square root symbol. You have a number down here. It's called the base. That thing is called the base. It is small, just so you know. So it's kind of like an exponent, and then it's smaller than the other numbers, but it's not above, it's below. It's called a subscript. You have a regular sized number here. That a is called the argument. So every log has a base and an argument. Okay? Logs are a little more complicated because there's 2 numbers there. So into this operation, you put 2 numbers. When you do a square root, you just put 1 number. What's the square root of 16? What squared is 16? Okay? When you do a log, you have 2 numbers. You have a base and an argument, and it asks this question. Pay attention right now. This is the important part. It asks the question, b to what power is a? Base to what power is argument? That's the question it asks. B to what power is a? When you answer that question, you've evaluated the log. Logs have an answer, just like the square root has an answer. What's the square root of 16? 4. What's log base 8 of 2? A number. Okay, so logs have an answer, a number. The way to figure out that number is to think about this question. B to what power is a? Okay. I'll give you an example. Here's a simple log. Log base 3 of 9. Please say that the correct way. We're big boys and girls. We should say that the right way. Log base 3 of 9. Log base 3 of 9 asks a question in your head to answer this, to figure out what number it is, 7, 3, 9, 2. To figure out what number it equals, you should think base to what power equals argument. 3 to what power equals 9? Well, 3 to the second equals 9. Log base 3 of 9 is 2. Okay. If you're thinking right now, wait, dude, what does this have to do with solving this equation? Just wait. We'll come back to that. That's like a couple lessons from now. We'll put it to use. Right now, I just want you to understand what a logarithm is. Okay. There's some important log values that come up. One of them is this. Log base, let's say, w of w. Well, wait a second. If you have a log and the base and the argument are the same number, think about that for a second. Basically, this is asking the question, w to what power is w? Well, to the first power. So if your base and your argument are ever the same for your log, it's going to equal 1. Another weird rule. Let's say log base p of 1. If your argument is 1, well, then the question is going to be p to what power is 1? Oh, wait. If you want to get out 1, the exponent, no matter what your base is going to be 0. Okay? 2 other important comments. No negative bases. Kind of like we don't have exponentials with negative bases. No negative bases, no negative arguments. Doesn't make sense. It just doesn't mathematically make sense. It's not allowed. It's kind of like square rooting a negative. It's just not mathematically a thing. So don't negative bases, no negative arguments. And your base can't be Your base actually has to be greater than 0. It can't be 0. Cool. Okay. This unit is going to be part calculator, part no calculator. So you should be able to evaluate these logs without a calculator. I'll do one of them with you. I'll do number 9 with you. Hey, what's log base 5 of 1/25th? Well, it asks a question. Base to what power is argument? 5 to what power is 1/25th? Oh, wait. If I want to get a fraction, I want a negative exponent. Okay, so it's got to be negative. But if I want to get 25 from 5, it's got to be a negative 2. Cool. Log base 5 of 1/25th is negative 2. You can plug logs into your calculator. I will show you how to do that at a later date, because right now I want to do no calculator. Okay. Pause the video. I want you to try and do all of these. 10. Unpause, and then I'll show you the answers. Go ahead, pause, try these. You should be able to do all of these. Okay, I'm going to fly through them real quick. Here's the answers. Number 5 is undefined. I would like to use that word undefined, not no solution. We're not solving an equation. We're evaluating something. It's like square rooting a negative. It is not defined. You can't put 7 to a power and get negative 49. Okay? These are small numbers. You should be able to do these. Careful here. Negative 3. Cool. Okay. Last thing I want to show you really quick. We'll come to this properties thing on next class. You can convert an exponential equation into a log equation. Okay? This is kind of a weird thing. The analogous thing is this. Don't write this down, just listen. Or you can write it down if you want. But here's the analogous thing. If you are given a multiplication fact, you can always convert that into a division fact, because multiplication and division are inverse operations. So every multiplication fact tells you a division fact. Hey, 8 times 2 is 16. Oh, 16 divided by 2 is 8. Those are basically the same thing. One of them is just viewing it as a multiplication problem or a multiplication fact. The other one is viewing it as a division fact. If you know the division fact, you can write the multiplication fact. If you know the multiplication fact, you can write the division fact. Because they're inverse operations, you can flip back and forth. The same thing is true with logs. If you want to write a fancy rule, some people like this fancy rule. It'd be a good thing to jot down, actually. I'm acting like it's a bad thing. It's a good thing. And this says if you have this this exponential statement, it corresponds to this log statement. Just like a multiplication statement corresponds to a division statement, every exponential statement corresponds to a log statement. You can flip back and forth between the two. We're not really solving a problem, we're just showing that you can do that. So since 6 to the 0 equals 1, log base 6 of 1 equals 0. How did I get that? I used this, I used that. Or you can also think about, if you want to go back and like check your answer, look how this works. The base down here comes over, bumps up the 0, so you get 6 to the 0 equals 1. That's kind of a cool way to like remember how the little pieces fit together. Okay? Another way to do it, like if I'm doing 13, is I remember, hey, in my log, whatever the base of my exponential is the base of the log. And then the exponent goes on the other side, so then 2 must be the argument. Log base 16 of 2 equals a fourth. Pause and try these two. They're exponential statements, make them into log statements. Pause and give it a try really quick. All right, here's what you should get. Log base 10, negative 3 goes over there, so the 0.001 must go there. This one, base is 3, exponent goes on the other side, so the 9 goes to go there. Why would you want to do this? Don't worry about it. We'll talk later about why you'd want to flip back and forth. The main thing I want you to be able to do right now is evaluate a log like this. Cool? Check? Okay, cool. All right, thanks for watching the video.